Data Manipulation Language, or DML, Part 1. In this nugget, we begin a 4-part series, or should I say mini-series, on the DML, or Data Manipulation Language statements in SQL. This nugget, we inaugurate things by using the all-powerful select statement. I've already familiarized you with this tool, with this statement, in plenty of the nuggets thus far. However, here we're formally introducing select from front to back, and I'll show you how we can use select to customize the columns that we get back from our database tables, as well as the rows. As we've seen thus far in our training, the select statement is really the DBA handyman, or handy person, to use the politically correct term, tool for any sort of data retrieval needs that you have in your MySQL database. On this whiteboard, you see the general generic syntax for the select statement. And we don't need to get sidetracked with a detailed discussion of this point, but I've been asked by colleagues and students, why is select considered a DML statement? Actually, select is kind of aside from either DML or DDL. We'll remember that DDL statements like create, alter, and drop are involved in object instantiation, alteration, and deletion, whereas traditionally DML, we think of the M as manipulation. Is select a DML statement? Yes, it is. And I'll show you as we go along that you can use select to actually modify data. However, in this particular nugget, I'm showing you how to run select to view data from existing tables, or as you've learned already, we can run select against functions to bring back results that way. Select, just like any other SQL statement, is not case sensitive. And after select, we can optionally provide values to display. Now, these are going to refer to either expressions or columns from one or more tables. Now, you've seen we've used select star in the past. Star is sometimes affectionately called splat by DBAs because it's kind of a descriptive term. If you look at the asterisk, it kind of reminds you, if you're of the same kind of juvenile bent as I am, of a bug splatted against a windshield. So that's where we get the term splat for the asterisk. However, we've seen that the asterisk or the star is especially helpful in select statements when we want to see all the columns from a particular table or group of tables. The only downside, well, there's a couple downsides to using select star. One is that unless you're using a where clause to filter your results and or a limit clause to bring back just a subset of your results, you can wind up with a lot of data with select star, far more than you need or want. The other thing with select star is that because that star brings back all of the columns in the table, A, you may not want to see all the columns of those tables, and B, you may want to specify a particular order of those columns. Select star not only brings back all of the columns from a table, but it brings them back in the sequence in which they were defined. Such that if we had a 4-column table where in our create table statement we defined column 1, 2, 3, and 4, we can bet dollars to donuts that select star is going to bring back the columns in that creation order. However, if we want to override that, we can always provide the column names after the select statement. We would just separate those column names with commas. We'll also see if we don't like the names of those columns, we can use the as keyword, which is formally optional, but I recommend that DBAs use it just to keep your SQL code as consistent and clean as possible. We can use as to alias or create a substitute name for those columns that shows in the row set. Alrighty, so much for selecting values to display. The from statement obviously is going to reference a view, a table, or a combination of the two. If we have joins defined, or if we have matching columns between tables, we can use from and specify more than one table to retrieve joined records from those tables. We'll be doing joins in a completely separate nugget. That's all you need. Select values to display from table name to bring back rows on your database. But as I've said before, the select star sometimes brings back too much information, and even if we brought back, say, 2 columns from a 4 or 5 column table, that still may be more than we need to see. Therefore, you need to become really familiar with the ways that we can filter data in our select statements. And there you have the chief tool is the where clause. And then after where, we're going to learn a lot of different ways to construct wheres. We have different expressions that we can leverage to customize the rows that are coming back. So basically, your values to display list, your column list, gives you control over the columns that are coming back. Your where expression controls the number of rows that come back. Now we're going to look at aggregate functions like group by and having in a future nugget, so I'll just leave those go right now. And certainly we want to know about order by and limit in this nugget, because where is good, as I said, for filtering the number of rows that come back. Order by is your sort tool. As we're going to see in the demo, the default sort order when you run a select is ascending. Keyword statement there is ASC. Nevertheless, you may, for instance, want to get a run of all the employees in your company and their salaries with the salaries displayed largest to smallest. There you would order by the salary column and specify descending or DESC. It's as simple as that. Do you think you can sort by more than one column? Yes, you can. You simply specify the columns that you want to sort by, separating those columns by commas, and you'll have first sort by your first column and then secondary sorts by your second column. Finally, we have this limit statement, which we've used in the past to just put a hard limit on the number of rows that are coming back. Thus far, I've just showed you how to run limit with a single integer afterwards. For instance, if we do a select star from employees, limit 10, we're going to get the first 10 records from that row set. However, what if we wanted to see records 20 through 30? How would we do that? Well, I'll show you in the demo, but I'll let the cat out of the bag right now by saying that you can actually provide two values with your limit statement. You can specify the number of rows to go down from the top of the row set that's coming back, and then you can specify how many records you want to see. So that a statement limit 20, 10 would say, in the row set results, go down 20 rows and then give me the next 10. Does that make sense? Therefore, limit does give you the ability as a DBA to limit not only just the first X number of rows that come back from your select statement, but you can show any collection of rows. Let's take a look at some examples of the select statement, this time focusing on specifying columns to retrieve. You'll see in code sample 1, select star from city. Pretty straightforward. We know that this is going to give us all of the columns and all of the rows from that city table. And if that's what we want, that's what we'll get. However, if we want to see just certain columns from that table, we can specify those after the select statement. For instance, select ID, name, population from city. Now again, as a point of review, the neat thing about this is that we can A, pull back a subset of columns instead of all of them, and B, just as importantly, we can specify the order. In other words, if I wanted to see name, population, ID, all I would have to do is order those appropriately in my select statement. Now here's a question for you by way of review. Let's say you wanted to run a select against city and only pull back 2, 3, 4 columns. How would you determine what columns are contained in the city table? Yes, I hope you answered. You can run describe. Remember, the MySQL specific describe command will return all of the columns and data types for a particular table or view. Therefore, describe is your friend in terms of giving you the ammunition or the information you need to construct a meaningful select statement. Now, code sample 3 shows us how to use aliasing, such that we're grabbing, in this case, 2 columns. First blush, it's kind of hard to see, and this backs up my suggestion to always use the as keyword for column aliasing, even though you actually don't have to formally. And that's the case with Microsoft SQL Server as well as MySQL, such that we're taking the name column from the city table, and the row set is going to have the column header city name. And notice, because we're using spaces here in our alias, we have to use single quotes to delimit that object. Otherwise, the MySQL parser would get confused here. City, space, name, it would just kind of bark at you. Comma And we're also pulling from the population column in the city table, but here I'm not using the as keyword, so it's a little bit more difficult to parse the code when you're not using as. As makes it very clear that you're doing column aliasing. By the way, you can alias tables as well. And table aliasing is especially helpful when you're doing joins. For instance, if we were pulling some columns from city, from two different tables, from city and country, let's say, we would have from city, comma, country. We could use the as statement just as easily to shorten city to CI, let's say, or shorten country to CO. And that's especially helpful when you're doing certain join syntaxes because you don't have to keep qualifying the names of the tables. In the fourth code sample, we have select star from world.city. This is an example of qualifying a table name. Remember, in MySQL, the name resolution path goes from database name to column name. So world.city is a way to be more specific when referring to the city column of the world database. Similarly to how code sample 3 works with aliasing table names and column names, you can do the same thing without aliasing by just being more specific and providing the database name and prepending that to the column name. Now let's take a look at using select to specify rows to retrieve. In code sample 1, we have select star from country where a particular column, end-up year, is greater than 1988. Now if you're wondering, when do I use the quotes and when do I not? One easy distinction, friends, is when you're dealing with a numeric data type like end-up year is obviously a date or some kind of integer value. Population here is certainly some kind of integer. Numeric data types do not require the quotes. You're going to need the quoted identifiers for strings, for alphanumeric values that use the string data type. Therefore, in the second code sample, we're selecting all rows from country where the population field is greater than or equal to 50,000 and the continent equals Africa. Now there's a few different ways to write this. And is an important operator. It's not case sensitive, and it allows you to specify, as you see here, multiple criteria in doing your select statements. If you wanted to do where population is greater than or equal to 50,000, and you also wanted to see where population is less than 25,000, you could say, for instance, where population is less than or equal to 25,000, or population is greater than or equal to 50,000. You see what I'm saying? And I'll show you how this works in the demo. So you've got these comparison operators, greater than, less than, equal to. You've got your logical operators like and or. The thing to remember about and or is that ands are processed before ors. So in code sample 3, we have select star from country, where, and then we've got kind of a complex set of criteria here. We've got GNP greater than 500 and continent equals Asia. So show me all the countries where the gross national product is over 500 from Asia, or the continent equals Africa. Best way to handle this when you have multiple criteria is to use parentheses to bunch your operations together. Since this first piece is a connection and is a connector between these two expressions, we would want to use parentheses in order to be really clear to the MySQL parser that it should evaluate this condition or this other condition. Or is helpful if you want to see as many rows as possible that fit either of your conditions. And of course, you're being more selective because you're taking both of your expressions, and both of the expressions on either side of the and have to evaluate to true for any rows to come back. In code sample 4, we have select star from country where population is between 500,000 and 1 million. So between and is another opportunity to customize your results. You can also throw in not. So if you wanted just the opposite, you could say where population is not between 500,000 and 1 million. Just showing you there's quite a bit of flexibility here on our where clauses. One thing I haven't showed you here is how to do partial string matches. For instance, if we wanted to see all the continents that began with A, we could say select star from country where continent like, and then in single ticks we can put our expression. So if we wanted to see all the continents that began with A, we would use the percentage wildcard. Now if you come from an MS-DOS background, you're used to seeing the star meaning an any kind of wildcard. In SQL, in ANSI ISO SQL, and in MySQL SQL, we use the percent sign to denote the any character. And you can use that any character however you want. In other words, if you wanted to specify continent that ends in a certain string, you would say, like let's say, anything that ends or includes states, you could do a like percent states percent. And that would take any characters before states and any characters after states and return those rows. Therefore, like is helpful for pattern matching on string data types. Okay, in sample 5 here, we're grabbing a certain number of columns, ID, first name, last name, and hire date, and we're ordering by hire date. So here we're grabbing a few columns. We're missing some text here, aren't we? We're going to have to say from a particular table. But whatever table that is, we've got the rows from. We're ordering by the hire date field. And remember I mentioned if you don't include the order date column, MySQL will, by definition, just give you the row orders as they exist in the database. If we were to say order by hire date with no identifier, then the rows would be shuffled and sorted ascending by that column. If you want to override that and do a descending sort, you'll provide order by column name descending, or DESC. Once again, to repeat, if you don't use an order by at all, then your rows are just going to come back however they are naturally in the file system. If you use order by with a column and no specifier, you're going to get an ascending sort by that criteria or by that column every time. If you want to override and do a descending sort, you would specify the DESC keyword after the column. And yes, you can mix and match. For instance, you could order by hire date descending, comma, last name ascending. You see? The best way to show you the select statement in action and get you comfortable with a lot of those operations and operators is to log into MySQL, attach to a database. In this case, we're going to be using the world sample database. Therefore, if you've downloaded this practice database to your computer, you should be able to follow along with every sample statement we use in the demo. Let's get to work. All right, here we are on Ubuntu Nugget, and our demo is introducing the select statement. As you see, I'm logged in, and I'm logged in as root. To introduce the select statement, I'll just show you some things we've already been using. Remember that select is useful in terms of pulling back variables and other dynamic data from the server. In fact, we use select to access those functions. So selecting against the user function returns the currently logged on user. And we can also bring back more than one function result, and we can just do ordinary expressions if we want to by using select with, for instance, some mathematical operation. 2 plus 4, let's say, and let's alias this as sum, and we can just directly add additional functions like cur date and user. And why don't we alias user as current user. All right, I see I made a syntax error here. Let me use my up arrow key. I have a rogue semicolon there. And there we go. So we're selecting 2 plus 4. Of course, that's going to give us the result 6. We've aliased that column to sum. We've brought back the current date stamp by running the cur date function. And we're bringing back the currently logged on user. So this is a simple example of using select to directly access MySQL's mathematical abilities, as well as to pull dynamic data from some built-in functions. Definitely hit up the MySQL reference manual to get a handle on some of the more commonly used system functions. All right, so let's do a run and show the databases that are in this instance. Of course, I've already downloaded and installed World, so I'm going to use World now, and let's get rocking and rolling. We can run a show tables to see what's there. Of course, as we've already seen, there's not many tables, city, country, and country language. And let's focus on the city column for now. You'll recall that we can get a run of the columns and data types by using the describe statement. If I can get my syntax together, that is. Looks like we've got case sensitivity here, so I'll say describe city with uppercase C, and we see our fields, ID, name, country code, district, and population, our data types, our nullability, and so on. Pretty straightforward. Why don't we run a select star from city, and we'll use the limit keyword to bring back just 20 rows. Looks like that the row sets are sorted by default by ID, which makes sense because as we saw in the describe statement, we have the primary key constraint attached to the ID field, and you'll recall from earlier lessons that when we add a primary key constraint to a column, MySQL will index on that field, and indexing means placing the rows in that specified order. I mentioned earlier in this nugget that we can use the limit statement to be more granular. Instead of just bringing back the top X number of rows, we could say, for instance, limit 10, 10. And what this is telling MySQL is to go down 10 rows and then give me the next 10. And sure enough, in this case, it gives us IDs 11 through 20. So keep that in your toolkit, the fact that we can use limit to grab just the top X rows, or you can use this more complex syntax where we're saying go down X number of rows and then give me Y number of rows. Simple as that. All right, let's run show tables again, and let's run some statements using some comparison operators and logical operators. Let's say we want to select everything from country this time, and we want to filter our results using the where clause to see, let's say, population is between 50,000 and 100,000. How's that? Boy, that doesn't look too good. This is a good example of coming back with too many columns. Wow. There's a couple ways that we can address this, and really the best way to address it is to run a describe against country and come back with just a certain number of columns. How about name and continent? Boy, select name and continent from country where population is between 50,000 and 100,000. There we go. Now that's much better, isn't it? Classic case of too much information, or TMI. I mean, that's going to look ugly on any terminal screen. Even if we output this to HTML or plain text, it's still way too much data. Take home message, use the specified columns. Use the minimum number of columns that you need to get done the job that you need to get done. Let's try a variation on that theme. We'll select name, continent, and we'll bring in the population column. Name, continent, population from country, where population is between 50,000 and 100,000. Press enter to give myself a new line. And let's specify order by population descending. There. So here we get our row set, 13 rows back, with just the columns we want, and we're bringing in the population column, and we're sorting it in a descending fashion. We can get even more jiggy with it by using up arrow to bring back our previous statement, by selecting name, continent, population, where the population is between 50,000 and 1,000, and in this time, let's do first a sort by population descending, then name. We can say ascending just for documentation purposes, but remember that by default the sorts are happening in an ascending fashion. Since I'm a stickler for documentation, I kind of like that. You're probably asking, okay, what happened? It doesn't look any different. Well, what you'll want to do here is look for a match between two rows in population. Because the first priority of the sort is by population and not name, you see that we're starting with 99,000 and then we're working our way down. So at first it doesn't appear that the names are sorted, but they actually are. For instance, you'll see we have two country names here with 68,000 population, American Samoa and Antigua and Barbuda. And because we are sorting in an ascending fashion, you'll notice that AM obviously comes before AN. Now we could make this a little bit more dramatic by just saying order by name ascending and then population descending. And there you'll see first priority of the sort given to the names. And then in the case of a match, then you'll have descending populations. Of course, we don't have any matches on country names here. Okay, thus far I've showed you the select statement with the where clause. We've used order by. We've used limit. Let me show you the distinct keyword. I didn't mention this to you in the whiteboard portion of the course. However, I want to show it to you here in the demo because distinct can really give you an extra advantage in terms of reducing misfires in your selects. And what I mean by that is this. As you see, I've run the show databases command, and I've in the background created a small sample database called selectdb. We're going to use that, and I'll show you my table run. You'll see there's just one called names. So if I do a select star from names, you see that I have 2 Bakers, 1 Malone, and 2 Smiths. Now, what if we just wanted to see all of the distinct names? In other words, not all this duplication. What we can do very simply is run select distinct, then the name of the column, from, and then the table. You see what I mean? So select distinct can be helpful in terms of reducing the number of rows you get back in the case of, in this case, there's a lot of duplication. There's 2 Bakers and 2 Smiths. Or also, you might be pulling values back from a column that includes nulls. 2 rows with a null would not be picked up by select distinct. You see what I mean? Select distinct is also excellent when used with the group by to do subtotals and just to aggregate values. In other words, how many Bakers do we have? How many Smiths do we have? But group by is going to be reserved for a future nugget, so hang on to your hats with that. All right, the final thing we're going to do in this demo is combine more complex where filtering with the like keyword to do deep string comparisons. And what you see on the screen now is that I've attached to the world database again, and I've run the describe statement against the city table, again, just to give us a field of view, so to speak, a frame of reference that gives us our fields and data types. And what we're going to do here, as I said, is write a more comprehensive select statement. Let's say we're going to select name and population from city, where, and then we're going to make use of parentheses here in order to separate out our complex criteria. So let's say in this case where population is less than or equal to 10,000 and district is like, and we'll say starts with A. Remember, the like works with strings, and you can use the percentage sign to represent any number of characters. We're going to put that whole ball of yarn into a single set of parentheses because this needs to be evaluated as one unit. And then let's say or population is greater than 100, let's say 500,000. How's that? So we get 539 rows in that set. Let's recall our original statement. We're grabbing 2 columns from city where, in the first expression, the population is less than 10,000 and the district starts with A, or the population is greater than 500,000. We can edit this by doing an order by city ascending. If I can get my syntax correct, let me up arrow. There's not a city table, there's a name column in the city table. So I'm going to say order by name. And that gives us a much better result. 539 rows still, but now our city names are ordered correctly. All right, so there's an example of a more comprehensive select. It's basically, friends, a question of formulating your question of your data as granularly as possible. In other words, I want to see, in this case, X number of cities that have certain population matches to them, and I want to see them ordered in a certain way. So the first key is to figure out what question you're asking of your data. The second is to use the select statement in the proper order. And you notice that we have select, where, and order by put in that certain order. That's going to be something that becomes second nature to you as you work on and on with the select statement. The select statement pulls the columns, from specifies the tables. Next, optionally, we have where to do row level filtering. Remember to use parentheses for complex evaluations. And finally, once you get those results back, you can optionally order them and limit them to filter back again what you're seeing. DML Part 1 of 4 Review. In this nugget, I formally introduced you to what is, in likelihood, the most commonly used DML statement, or should I just say SQL statement in general, for MySQL, and that is select. I hope you're really comfortable with the purpose of select now, as well as its syntax. I showed you how to leverage select to retrieve just the number of rows that you want and no more. In other words, how we can customize column retrieval using the star or columns or alias names for those columns, as well as customizing row retrieval using the where filter keyword, as well as the order by sorting tool. I hope that this has been informative for you, and I'd like to thank you for viewing.